A logger with zero engineering education builds a locomotive in a barn using salvaged parts. Professional engineers call it impossible. The design violates every principle they teach. The cylinders are mounted vertically on the side. The power transmission uses industrial sawmill gears. The whole thing looks like it was assembled by someone who'd never seen a real locomotive. But it works. Over the next 65 years, manufacturers build 2,761 of them. It becomes the most successful geared locomotive in history. Then the corporation that built them erases the inventor's name from the catalogs. 1911. A Lima Locomotive Works salesman walks into a logging company office in Oregon. He opens his catalog to page 47. The Lima-Designed Geared Locomotive, revolutionary engineering, detailed patents, technical drawings, performance data. The name Ephraim Shay appears nowhere. Lima is selling the Shay locomotive as their own invention. The man who actually designed it isn't even mentioned. This isn't unusual. This is how Lima sold Shays for 30 years. Ephraim Shay died a millionaire in 1916, but today, most people think Lima engineers designed Shay locomotives. Museum plaques credit Lima Locomotive Works. The logger who built the first one in 1880 is a historical footnote. How does someone revolutionize an industry, get wealthy, then disappear from the story of his own invention? The answer reveals how corporations sell innovation versus how it actually happens. 1880. Northern Michigan. Ephraim Shay runs a lumber operation near Herring. He's 44. No engineering degree, no technical training, just 20 years logging experience and a problem costing him a fortune. His logging railroads keep derailing. Standard locomotives can't handle temporary logging track. The track is rough, curves are sharp, grades are steep. Conventional locomotives have rigid wheelbases that twist on uneven track. Derailment. Sometimes they tip over. Shay loses days of production every month. Professional engineers tell him to build better track, grade it properly, space ties precisely, reduce curves. Shay doesn't have money for that. Logging operations are temporary. Clear the forest, pull up track, move on. He needs locomotives that work on imperfect track. So he experiments. First problem, rigid wheelbases. Standard locomotives have drive rods connecting wheels directly. Any track twist transfers to the frame. What if wheels could move independently? What if the locomotive had multiple trucks that pivot and flex? That creates a second problem. If wheels aren't connected by rods, how do you transfer cylinder power? On standard locomotives, cylinders drive wheels directly through connecting rods. That only works with rigid mounting. Shay needs different power transmission. He finds the answer in sawmills. Geared drives, shafts and bevel gears transmit power around corners between moving parts. What if he mounted cylinders vertically on one side, drove a crankshaft, and used bevel gears to transfer power to a driveshaft? The driveshaft connects to gears on each truck. Each truck pivots independently, but all receive power through the geared system. Engineers think this is insane. Geared drives are for stationary machinery. The gear teeth will strip under load. Off-center cylinders make locomotives unstable. The design is clumsy and inefficient. Shay ignores them. 1881. Shay builds the first prototype in his barn using salvaged parts. Vertical cylinders on the right side. Crankshaft driving a longitudinal driveshaft. Bevel gears connecting each truck. It looks bizarre. All the weight is off-center. Cylinders stick out like a tumor. But it works. Trucks pivot independently over rough track. Geared drive transfers power smoothly through sharp curves. No derailments. Shay runs it for 6 months. No failures. Gears don't strip. Off-center design doesn't cause instability. In fact, it helps on curves. Heavy side pulls the locomotive around the inside naturally. The flaw is an advantage. Other loggers want them. Shay can't build fast enough. He contacts Lima Locomotive Works in Ohio. Lima is small, struggling against Baldwin and Alco. They agree to build Shay's design under license. Shay receives royalties per unit. First Lima-built Shay delivers in 1882. By 1885, Shays are Lima's primary product. By 1890, they dominate logging railroads. The design professionals mocked becomes the standard. Lima sells hundreds. Shay collects royalties on everyone. But Lima's marketing changes. Early catalogs say Shay Patent Geared Locomotive. By the 1890s, Lima Geared Locomotive. By 1900, some materials don't mention Shay at all. Sales reps tell customers Lima engineers developed it. Technical papers describe it as Lima Innovation. Shay's name gets edited out. Why? Corporations sell credibility. A locomotive designed by professional engineers in a modern factory sounds credible. A locomotive designed by a logger in a barn doesn't. Buyers trust degrees and research departments. They're skeptical of uneducated inventors. Lima rewrites the story to emphasize their engineering, minimize Shay's role. If you're interested in stories like this, subscribe to Rail Systems USA for more untold railroad history. Shay doesn't fight it. He's making a fortune from royalties. By 1900, Lima sold over 1,000 units. Shay is a millionaire. He doesn't need public credit. He needs royalty checks. Fighting Lima over marketing might jeopardize the relationship. He stays quiet and collects money. But there's a consequence. By 1920, most railroad people believe Lima engineers designed Shays. Shay dies in 1916. Obituaries mention he was a logger who held locomotive patents, but the public doesn't connect Ephraim Shay with Shay Locomotive. They think it's a Lima product named after a place or design type. This shapes how we understand innovation. The popular story features credentialed experts in corporate labs. The real story features non-experts solving practical problems with unconventional approaches experts reject. Shay had no training. He didn't know what was impossible. So he built something that worked despite violating design principles. And it worked spectacularly. Between 1880 and 1945, Lima built 2,761 Shay locomotives. They operated on logging, mining, and industrial railroads across North America and dozens of countries. The design outlasted the logging industry it was built for. Shays kept running into the diesel era because they handled track conditions that defeated advanced locomotives. Final irony, today only dozens survive. Most were scrapped when logging closed. Survivors are in museums or tourist railroads. Most plaques mention Lima Locomotive Works prominently. Some mention Ephraim Shay. Many don't. The corporation gets credit. The logger remains obscure. Was this theft? Technically, no. Shay licensed his design, he was compensated, he got wealthy. Lima didn't violate the legal agreement, but they violated historical truth. They let the public believe professional engineers designed the Shay when a self-taught logger invented it. They erased Shay because an uneducated inventor didn't fit their corporate image. The question, how many other innovations have similar stories? How many breakthroughs credited to corporations or experts actually came from outsiders who didn't know conventional rules? How much innovation history is marketing mythology? Ephraim Shay built 2,761 locomotives without an engineering degree. Lima Locomotive Works sold 2,761 locomotives by letting buyers think their engineers designed them. Shay got rich. Lima got credit. History got it wrong. The man who proved you don't need credentials to revolutionize an industry became a footnote in his own invention's story. The ugly, clumsy, impossible design experts rejected became the standard for 65 years. And 2,761 times, someone chose the logger's weird geared design over what professionals recommended. That's Ephraim Shay's real legacy. Not Lima's marketing, not corporate innovation mythology. The truth: a logger with no degree built something better than the professionals could. Sometimes the people who don't know the rules are the ones who change them.